Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Wa maghfiratuhu and greetings to my lecturer and to all of our friends. So, today we will be presenting about our group project of group 10 for the sequence and progression topic. So, our team is made up from four people, which is Abdul Afif Abdul Razak, Fard Amir Nizam bin Shahrul Nizam, Muhammad Hazimi bin Saimi, which is me, and Muhammad Shazwanuddin Fitri bin Saidis. So let me introduce what our group project is about. So sequence provide a systematic way to track incremental changes in storage needs, while series enable the summation of these incremental values to project cumulative space requirement over a specific period. These tools allow for precise forecasting, helping decision makers align space availability with operational needs while managing costs effectively.
Hello everyone, my name is Abdul Afiq bin Abdul Razak. So I will explain a little bit about the filler table. This table summarizes the facts, ideas, learning issues, and action plans for solving production-related problems. For instance, we analyze the initial capacity of a warehouse and how it grows annually. We consider how machine wear impacts production over time and explore strategies for sustainable growth. This table serves as the foundation for the tasks we will address next.
So for task number 1, a warehouse has an initial storage capacity of 1000 units and plans to expand by 100 units each year. Number 1, what will be what will the capacity be after 6 years? Question number 2, find the total storage capacity accumulate over 8 years. And question number 3, if demand grow faster than planned expansion, how could the warehouse adjust? Now for the solution task number 1 for question 1. Using the arithmetic progression, which is the number of term in the sequence equal to the first term of the sequence plus the common difference and multiply by the number of term minus 1 in the bracket. So from the question earlier, the number of sequence is 6. So T6 equal to 1000 plus 100 multiplied by 6 minus 1 equal to 1500 units. So move on to question number 2. Using the formula of the sum of arithmetic sequence, which is Sn, the sum of the number of term equal to number of term over 2 multiplied by 2 times the first sequence of the term plus the number of term minus 1 and multiply by common difference. So from the question, we get is as the sum of number of term 8 equal to 8 over 2 times in the bracket 2 times 1000 plus x minus 1 times with 100, which is the common difference from earlier question, equal to 10,800 unit. So for question number 3, which is the if demand grow faster than plant expansion, how could the warehouse adjust? So for the not formula for the so to solve the problem earlier, we need to build additional storage facilities or expand the unit by 200 units each year.
Solution task 2. A production line produces 200 units in the first hour, increasing by 15 units every subsequent hour. First, calculate the production rate at the 5th and 10th hours. Second, determine the total units produced by the end of 8 hours. Third, if the production line experiences machine wear over time, how would this affect the production rate? Develop a new model accounting toward this factor. The solution for this is, for the first one, we calculate the 5th and 10th hour using the formula Tn equals to the first T5 equals to 200 plus 15, 5 minus 1 is equals to 260 units for the 5th hours. For the 10th hours, 200 plus 15 times 10 minus 1 equals to 335 units in the 10th hours. Question 2, the formula is for the sum of 8 hours is equals to 8 over 2 times with 2 times 200 plus 8 minus 1 times 15. It will equals to 2020 units. And number 3, where reduces efficiency over time, causing a gradual decline in the rate. New models equals to if decline is t% per hour, adjust production as new rate at th hour equals to 200 plus 15 t minus 1 times a minus d over 100 power to the power of t minus 1.
So for the last question, which is task 3, a production line doubles its output each hour, starting at 200 units. Find the production rate at the 4th and 7th hours. Calculate the total units produced over the first 5 hours. And the last one is the critical thinking. Evaluate whether this production strategy would be practical in a real-world setting considering resource limitations. Suggest modifications to optimize the production. So for the first question in test 3, we use the formula Tn equals to A R power of n minus 1. A is the initial production rate, R is command ratio, and N is the time. So we substitute the A with 200, R with 2, and the N is 4. So we will get the answer 1600 units. For the 7 hours, we just substitute the 4 with 7 and we will get the answer 12,800 units. For the second question, we use formula Sn equals to A in bracket R power of n minus 1 over R minus 1 and we will get the answer 6,200 units. And for the critical thinking question, the answer is exponential growth requires exponentially increasing resources, which can quickly become unsustainable. Practical challenge include resource scarcity and the risk of equipment overheating or failing under high demand. To address these issues, it is advisable to cap growth after a few hours to prevent overload. Additionally, investing in automation can improve efficiency and help handle higher outputs with fewer resources.
Discussion. Task 1, the warehouse pace expansion. The warehouse holds 1,000 units and grows by 100 units each year. In 6 years, we can calculate its capacity and total capacity over 8 years. If demand grows faster than the space, we may need to expand faster, use space better, or rent storage. Task 2, production line growth. The production line starts at 200 units per hour and adds 50 units each hour. We can calculate the output at any time. However, machines can slow down over time, so the plant should adjust as needed. Task 3, doubling production. The production starts at 200 units and doubles every hour. This is fast but can run into limits like resources or machines breaking down. A better plan might include limits or a mix of growth rate.
So, for the conclusion, the sequences and series have been important in providing the mathematical approach necessary in tackling very crucial problems that relating to warehouse and production management. With in-depth analysis of increased warehouse space along with a growth in production, the tools are enabled to provide accurate forecasting, decision making, and resource allocation efficiently.
To wrap up, we have explored how mathematical concepts like arithmetic and geometric sequences can be applied to real-world production challenges. These models not only help us understand growth patterns but also enable us to address resource limitation effectively. By analyzing the scenarios and proposing sustainable strategies, we can ensure efficiency and long-term success. I think that's all for our group. Thank you for your attention. Bye.